We're going to talk about now the Hunter GFP 9700 wheel balancer and road force machine. We'll talk more about the road force. For now, go ahead and point to the arbor. Where we mount the wheel, we're not just going to spin balance and find where the light area of the wheel is. With this roller, it will also come down and push against the wheel, simulating the road force, the weight of the vehicle on the road. This puts about 1,400 pounds against the wheel. So you don't, for whatever circumstances, put your hand in here and they got a hood, it protects you pretty good. It'd crush your fingers pretty fast. But anyway, this is going to simulate and actually try to measure, and it can measure quite accurately, how round the wheel and tire assembly are. So that's what we're going to demonstrate here. First of all, let's now look at the wheels. And we've got aluminum wheels. These two are definitely aluminum wheels. We've got the aluminum spoke. This is definitely an aluminum wheel. If you've got a magnet, rested against it, of course, it wouldn't be attracted. These are lighter weight aluminum wheels. But this one here, I don't know why it's painted green, but if you see a wheel, it's kind of like all the little areas here are like stamped out, or it's just solid black, and it's got a thinner lip here. Can you bring that out? You got a thinner lip, whereas an aluminum wheel is a thicker lip, even thicker than this one quite often. And steel wheels, of course, are cheap, quick to manufacture, keep the costs down, but easy to balance. Aluminum wheels, well, I can hammer on weights here, but we'll show you tape weights as well. Let's go ahead and go through the mounting procedure. Let's do a steel wheel first. So I got my choice. Generally speaking, for a steel wheel, I got to find the right cone. That was too small. I got to find a cone that goes about, part way up the ramp of the cone. And I think that's what I got here. I'll put the cone on. Here's the big wing nut. We're going to use. I guess it's time to buy a new one. So when I put the wheel, see how it comes part way up the cone here? I selected the right cone. Now this cup is going to push the wheel. We're going to push the wheel up the cone. And ultimately what we're really doing, we're putting these flat areas against this flat face. And I want the wheel mounted and solid against that face. If we're not solid against that face, the machine is going to measure a warped or bent wheel. And that's not good when the wheel's a good wheel. I would say 90% of the error issues that people have because they didn't mount it correctly. I want to show you one little trick. One little trick on this machine. One little trick. The multi-purpose pedal down here. If I pump that pedal, I'm going to hang on the knob here. If I pump that pedal 2 or 3 quick ones, it will spin the arbor for me. Right the other way. See that? Now, using the same pedal, I'm going to hold it, and it acts like a brake. And I can grab the wing nut now and really give it a tight. So again, I want this tight. I want that flat area of the wheel tight against that flange or that flat surface we showed earlier. This wheel, I'll give it a spin, and I'll just kind of look it over. And it looks like it's good and true. It's not bobbing up and down. It's not wobbling around because I may have, assembled it or mounted it incorrectly. All right, let's come in a little closer. Come around front. And I'm going to use this same pedal in a moment. I'm going to bring this little measuring piece out. I'm going to bring this little piece out and get it just under the lip of the steel wheel. Maybe you want to show where that lip is. Okay, I want to get this just under the lip. Now I've done the same thing on the other measuring device. Now look at the screen. I'm going to pump the pedal slowly, just one good slow one, and it'll update those values on the screen. Whoops. You see how it has a 177 on the left side, 6-inch width on the top, 14.6. Let's see what happens when I pump the pedal. Okay, well, I guess this wheel's been done before on this machine. Didn't change too much. We got a little difference. Okay, so I let go. I let go of these things. Let me go back to home. Okay. Now I need to select, well, which type of wheel weight do I want to use? So if I look at the broken weight here, I'm going to select the K2, because that lines up with that box. K1 lines up with that box, etc. Okay. Please. Oh, programming changed. I'll go back. Actually, we're trying to find out, we want to do hammer weight, a tape-on weight, or another type of weight. I'm going to hit the K4 box. Okay. We're going to hammer on the outer and the inner. That's what this little emblem is depicting. If I'm going to tape weight on the middle and a hammer on the inside, then I would simply move over. But we're going to move on me. We're good. We're going to hammer on some weights. Okay, now a few minutes ago, we pointed out that the pedal on the floor has 3 purposes. And of course that is to spin the arbor automatically if I want to, or it spins it for me if I pump the pedal 2 or 3 quick times. If I just simply push the pedal down and hold it, it'll act like a brake, so I can tighten the nut. And then thirdly, if I can pump that pedal to, of course, enter the dimensions. We were back in entering the dimension mode. Let's now look at this knob. This knob has multiple purposes as well. It's right now on the passenger tire. I rotate it. Now on light truck, I rotate it again, and it takes the road force roller off. Remember how we pointed? Can you see that? Remember we pointed out the roller earlier? Maybe I just want to spin balance. I don't need to road force it again. But we're going to go ahead and road force, and it's a passenger tire for a small car, passenger car. And we've got the dimensions. If you look over here, you'll see the dimensions that were entered in. We've selected our weights. We're ready to pull the hood down, go ahead and back up. And the machine's going to ask me to do something. That's why I want you to see this. It says, did I measure the tire pressure? Let me show you what this machine can do. I can use this same knob, and I can increase the inflation rate. I'm going to say 33 psi. I'm going to lift the hood. Here's actually an air hose, because this machine's plugged into the shop air. And I'm simply going to hook it on. And I'm going to have to hold it here. There we go. Can't leak air. But look at the screen. So it's adding air for me. And it likes what it sees, so it turns the tire green. We're ready to go. I can now, and be sure and put this air hose back in its little pocket. The sensor there that tells the machine the air hose is where it should be, so you don't spin balance the wheel with the air hose on and rip the air hose off the machine. Okay, we're ready to balance. Here we go. It's asking, did you tighten the nut, the big wing nut? Yes, we did. The roller was on there first, measuring how out of round the wheel assembly is. And then the roller rolled away and spun the wheel to determine where do I need to put some lead, because the wheel is light. All right, so what the numbers mean. This inside wheel, I'm going to tack on a 1/2 ounce weight. The outside one, we'll get it green. In fact, I'm just going to put the start button. And that'll rotate the wheel. Oh, I did a check spin. Oh well, not a problem. It doesn't like it, does it? I have to have the hood up. But this little number, 0.006, that's how much road force or out of roundness and a force would cause a vibration. That is a very true tire. We rarely see 0.00 something. It's usually, 1 or 10 or 15. We like to see this number below 25. So this wheel's pretty round. Okay, back to hammering on the weights. So when it's green, it means I need, at 12 o'clock on the wheel, see this white mark? I go straight up and I'm going to hammer on a 1/2 ounce weight. Okay? And it just so happens, well, I had a 1/2 ounce weight. What did I do with it? I'll use this 0.75. If you're within 0.25 of what it says, just fine. For the sake of the video, make life a little faster. Okay. Now I'm going to push the start button. You're going to see this one over here turn green. And it moved the wheel. You see that? I'm going to hit it again. I'll hit start again. And it moved the wheel back to where this needed to wait, which we've already got accomplished. But now I want the wheel in the right place to put a weight on over here. When it's green, I'm ready to put a weight out here. Go ahead and move on around. And let's see if I can make this work. Now, I can't use weights with a great big old hook on them. That's for an aluminum wheel, a certain kind of aluminum wheel. I need these steel wheel weights that have a real small opening. Okay? So, and if you reuse some weights, I always try to squeeze the little claws back down a little bit. Maybe I could fit a nickel in there, I don't know. You know, that's kind of a distance, that kind of a gap. Now let's hammer this on. I look at the arbor, I'm going to try to just do my best. Yeah, that looks like 12 o'clock. I'm smacking. I lay the weight in the little groove there. I'm going to smack the actual claw. Now let's do a check spin. That's what the machine wants me to do. So I just simply pull the hood down, and it takes off and does it for me. Notice the roller was away, meaning, hey, we're doing a check spin. And I got lucky and I got both sides balanced. The road force is a very low measurement. Again, we like to see it below 25 generally on a passenger car. And that, my friends, is how to do a steel wheel.